Well, it is a nice spring day in Kentucky, and I am getting geared up for a new project on the Ordinary Engineering channel. This is another one that's really not very heavy on the engineering and more on the ordinary, but it is a car repair that I think a lot of people may find useful. There are other videos out here that show how to do this, but I'm going to try to help a little bit with the why I'm doing it and what the diagnosis is. But I have a 2006 Chevy Trailblazer that my son drives that has developed a pretty bad vibration and noise in the front end. And he's off at college. He's off at college driving this thing, and he came home for the summer and seemed to be unaware, as I notice a lot of the younger people are, of what is going on with his equipment. Kind of clueless, actually, but I'm working with him. He's getting better. And this particular car it's got a vibration in the front end that it goes really once per cycle of the wheel. You can feel it's at the same frequency as the rotation of the tires. Doesn't map to the transmission. It doesn't map to engine speed. It really maps to tire speed. And so that begins to narrow it down. You begin to think, okay, well, what rotates in the front end of the car that could be causing this kind of noise and this kind of vibration? You think in terms of maybe brake rotor. You think in terms of the front axles and CV joints and wheel bearings. And on this one, I'm pretty sure it's wheel bearing. And the reason is again, it's a kind of a not grinding, but groaning, bumping noise as you pick up speed. A lot of vibration in the car, and I'm just going to be quiet and let you listen to it for a second as I pick up some speed in the neighborhood here. See if you hear that noise picking up. And it is picking up. So I'm doing about 40, so you can hear that whoop, 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 and you can feel vibration in the steering, vibration in the car. So I'm pretty sure this is a wheel bearing. So I've already ordered the bearings. They just arrived today from Amazon.com, and I will be getting those out and setting up to show you how you can replace wheel bearings on a 2006 Chevy Trailblazer, and talking a little bit about the engineering behind that, since I am calling this an Ordinary Engineering channel. So what goes on with a wheel bearing and what does it do and why does it matter? Some people may not care, but I'll talk about that as we go. So that's all for now, and we'll pick this up a little later. Alright, so here's the car. This is the 2006 Trailblazer, and I'm pretty sure that this is the wheel that's giving me problems. And so in addition to what I described a while ago as the symptoms on this wheel, I did check the wheel bearing. And the way you can check the wheel bearing is you jack the wheel up, get it off the ground, and then you grab it and you wiggle it and see if you can feel play at all in that bearing. And I do feel play in this bearing, so I'm convinced that this is the bearing that's giving me the problem, that it's shot. I'm going to go ahead and replace them both. I'll show you on this one wheel. It'll be the same thing on both sides, and we'll go ahead and get started here in just a second. To do this job, you're going to need a number of tools, nothing major. The biggest thing you're going to need is a 35mm impact socket, or socket with a long breaker bar if you don't have an impact wrench. I do have some air tools that I'm going to use, but you can also do this with hand tools. If you have a long breaker bar, you can break things loose. But I'll show you that in a second. But there is a 35mm nut that's on the center shaft, on the shaft that the axle is driving the wheel, and then you've got your regular nuts, lug nuts that hold the wheel on, and there's I think 3 bolts and nuts that hold the bearing itself in. So it's a relatively simple fix. To show you how to do this, you can save yourself a lot of money. If you get this done at a car shop, you're going to probably pay in the range of $500 to $800 to have these wheel bearings replaced. You can get wheel bearings on Amazon.com shipped to your house for as little as $60, which is what I bought. Don't plan to keep this car super long time, so I figure if it lasts 30,000 to 40,000 miles, that's not too bad. And so it's going to be just the $60 I invested in 2 bearings plus my time, compared to spending $500, $800, maybe even $1,000 depending on your mechanic. So this is a good way to save some money. I'll show you how to do it, talk a little bit about the engineering as we go, and be back in just a second. Okay, first thing you want to do is you want to get this cover off. The the wheel so you can get to the lug nuts, and you can do that with just a simple screwdriver. There's a place for the screwdriver to go. You just go in and just pry that loose. It'll come right off. Very simple. Now what we have to do is we have to get these lug nuts loosened. We're going to loosen the axle nut. We're going to loosen this axle nut while the wheel is down so that it comes loose well. We're gonna take this nut off. We're going to use this impact wrench. We're going to loosen it, not take it off. This is 35 millimeter. We'll use that to loosen it. I'm going to turn the air compressor on and get going. Okay, now what we want to do is we want to jack the car up, and then we'll take these lug nuts off, and we'll get the wheel off, and then we'll take the center nut off now that it's loosened. And so I've got a jack underneath the frame. I'm going to lift it up, get it on a jack stand, and then we'll be able to get the wheel off. That wheel off. Okay, with this loosened from before, it'll come off by hand. So what we want to do with this is we want to take this off, and these brakes, or the new hub that I ordered, unfortunately did not come with a new nut. And normally you would want a new nut come with this, and so again, like I said, I bought a very inexpensive hub to go on here. So I'm going to have to reuse this. But in order to do that, in order to get this this hub off, I need to tap this shaft. So what I'm going to do is just flip this nut around backwards where hopefully I won't damage it, and I'm going to smack it kind of on the back where this washer is. Should be fine, shouldn't hurt being able to get it back on, and that'll give me a nice surface to give a good whack on that axle without damaging the threads on the axle or spreading it out. So I'll be back to do that in just a second. Okay, before we do anything else, we need to take the brake calipers off, and in order to do that, there are a couple of 18 millimeter bolts that hold that on. So we'll take those off, then we'll come back to getting ready to knock to tap the axle and loosen it up. Okay, well, let's see how this works. Hopefully we won't have to apply too much force. Oh, may need my cheater bar. I'll be back. Okay, we need some more force here. Now, something that all mechanics know and view as their friend is what we call torque, additional torque. So when a screw is put in place, the amount of power or force that goes into it is defined by torque. And what torque is, from an engineering or physics term, it's force multiplied over distance. So it's force applied out at a certain distance around a rotational point. So when you put a certain amount of force at this point on this handle, it puts a certain torque here. However, that torque, like I said, it's the amount of force multiplied by the distance that it's acting over. You can increase that torque a lot by putting the same amount of force out at a longer distance. And that's where leverage comes in. And so that's what allows you to break loose a bolt that you otherwise couldn't. So by putting force way up here instead of way down here, I'm able to drastically increase the amount of torque on this screw head. And actually, if I go the right direction, I probably could have got it the first time. And I'm trying to tighten rather than loosen, so that may help as well. But we're going to see if we can loosen this and just watch by the addition of a long lever how easy it is to pull this bolt. There it goes. No big deal. So, cheater bar, this is called. Piece of pipe to extend this force range. It's the mechanic's best friend. And here is the other one. And we will also use our cheater bar there. There we go. And I'll go ahead and take that off and get that out of the way. So, talking about torque, engineering and things like that, physics is a wonderful thing, and we don't think about in everyday things just how much at play physics and engineering are. So, you know, we sometimes take for granted the marvel of engineering that an automobile is. And it's, you know, we went for thousands of years in the world with nothing but horses, buggies, and wheels. And then in the last 150, 200 years or so, the knowledge has just exploded. And the ability to break through, to deliver inventions that we've never dreamed of before. The car, I think, is one of those. And so, the rotor's a little loose. We'll break this loose. So, the reason this is kind of jerking around like this, or the brakes are kind of touching this rotor, and they're kind of tied up against it. What I'm doing, I'm just pulling this caliper off, which has a couple of brake pads in it. I'm going to pull it off, get it out of the way, so I can work on this. There we go. So that's now free. I'm going to go get a hanger to hang this where I don't damage the hose, and I'll then proceed from there. I'll be right back. Okay, to take care of this caliper arrangement, I'm just going to take an ordinary clothes hanger, and I'm going to fix it up to hang this thing up. I think that will fit right through there. Yeah, perfect. And I'm just going to take it and pop it right up through here and do that. And I think that'll make a nice little place to hang this so that it is out of the way and not putting pressure on the hose if I can get it to stay there. Let's try that again. It's a little bit heavy. Opening up my hanger. Just set it right there. We'll just set it right there and let it sit there. It'll be fine. Okay. Onward. Hanger was a good idea, but it didn't work so well. Okay. Brake rotor is already loose, so it should come right off. We'll set this off to the side. Now what we need to do is we want to get this loosened just a little bit to get ready to take it off here shortly. But before we do that, what we need to do next is we want to take our wheel bearing assembly out. This is what we're here to replace, and I'll go show you that I have a new replacement for this part. But to get it off, there are 3 bolts, one here, and one here. And those are accessed from the back. And that requires an 18mm socket, which rolled away. I'm sorry, it's not an 18mm, it's a 19mm. Let's check that out. Nope, 18 after all. Put an extension on there. That's what we need. Okay, so let's see if we can loosen this up. Go back to our cheater bar, back to physics for leverage. There we go. Very nice. Go ahead and break these other ones loose. Rolling around. Okay, now 3 bolts are out. At this point, we probably need to go ahead and get the cable loose that goes down to this thing. So there's a cable that goes down to it, and there's a couple of connection points here. So the first connection point is right here, and that is looks to be just where it clicks into a metal frame. And I think we can just pop that out, which we just did. So just pressed on that to knock it loose. The second connection point is right here, which is a little metal, not metal, but a little plastic clip. And I think if I just get my screwdriver and open that tip up, yep, that opens up. So this will come loose. We have another similar connection point over there, and then we go into a connector over here. Okay. Okay, the last thing we have to do to get ready to put the new wheel bearing on, or remove the old wheel bearing, is we gotta disconnect this connector right here. So I will attempt to do that without blocking your view as much as I can. But get it loose. I have an upholstery tool removal tool that works pretty good. You can see this tool that we can just slide underneath here where it connects, and that should pull right out. Let's take this. You can see there's wires in the back part of the connector and this connector here. Let's pry this loose. Just a standard little plastic thing. I don't know why. It's part of the connector assembly. Not sure why GM and other people designed that way, but it's like a brace of sorts that locks this other connector in, and you put it in at the end after you've reconnected the connector. So you save that when it comes out. So take it out first. There's a place up in here that you can loosen. You take the top piece out, then you pry this loose part right here, and the connectors come apart. Almost. The cable is now loose. This bearing will come off. So, okay. So the next step here is we want to get the shaft broken free from the bearing so we can pull it off. In order to do that, like I was telling you earlier, we've got this nut on the shaft. What I'm going to do is I'm just going to tap it. Don't have to hit it real hard, but I'm going to tap it once or twice with this hammer to break it loose, and then it should come off. Okay. There we go. Well, I think it's good, huh? Let's try it again. There we go. Now, let's have to take the nut off. And it should come right out. There you have a wheel bearing removed. Now we're going to save the shield for the next one. But that's it. Now, just to talk a little bit about what a wheel bearing is and what it does from an engineering standpoint, this is a very critical component in any car, any mechanism. What this does is it's completely about managing friction in a rotating device. So to turn for your car going down the road, these shafts are turning, the wheels are turning, everything is moving. This bearing is what takes all the force of the wheel as it turns. And so as your wheel turns, the wheel is attached to these bolts and it's turning like that. The hub is stationary. It's just bolted up to your car. And inside here, there are roller bearings that take all that load. And so that's very critical to the function of your car. And that's what keeps from having metal rubbing against metal and grinding out. Inside a bearing, you have like balls or rollers. They roll around and they make the motion really smooth. And as long as those aren't worn, the bearing works great. But over time, they will wear, and then they start to cause friction. And as they get rough and friction starts to build up, they start to drag and they get loose and they wear out, and then you got a problem, which is what we have here. So that's why we have to replace it, and we'll go get the new one. Okay, I'm back. Now, this is the new bearing, and hopefully it will be a nice drop in. And this is unbelievably reasonable. Like I said, I bought this on Amazon, and I could put the link up, or I can tell you where. There's multiple versions. They all look similar, but this I'm sure was made in China. But I paid $60 for a set of two, and I figured, gee, for $60, how bad can it be? So we're going to pop this thing on here, and if I have to come and do this again in a few months or a year, it won't be so bad. For $60, I'm willing to take the chance. So here's the new one. Let's look, see how close it is to the old one, just to make sure this all looks just right. In fact, it has all new features to pop it in, so we may just use all those. So let's go ahead and start putting it in. Start it through. Okay, now. This guy somewhat in place. And see if we can at least get one screw started. Okay, there we go. One. There's two. And last but least, there's three. Now, we'll tighten those back down, and then we'll look at tightening up the shaft. Extension. This really isn't a hard repair and can save you a lot of money. So I'm at most maybe 35-40 minutes into this now, 30 minutes maybe. Yeah, about a half hour, and I'm going to be done pretty soon with this wheel. And you calculate the value of your own time. What do you get paid? How much do you make an hour? I figure by the time I'm done with this, it will have netted me a couple $100 an hour in savings. So is that worth your time? Something to think about. A lot of people are afraid to work on their cars, afraid to try anything, or they say, I just don't have time. Well, again, if you truly don't have time, that's one thing, that's understandable. But if you would trade leisure time for a few $100s an hour to do this at your home without having to pay the cost of a garage, when you take your car to a garage, even though it may take an hour for a mechanic to do this, in 30 minutes if he's good, he's fast, you're still paying. You're going to pay for a few hours of labor regardless of what it takes. They've got standard calculations that they'll charge you for, and you're going to pay it at a shop rate of $100 to $120, $130 an hour is what they're going to charge you, because they got overhead in their facility, and I don't fault them for it, They have to pay for the equipment, they have to pay the rent, they have to pay for everything that they're dealing with to get that repair job done. But you can do it yourself, and your shop rate is 0, and you can save that money, and that can be value that you bring to yourself. So at this point, I have this tightened up nicely. I am going to make sure I have it torqued to the appropriate spec here just a little bit, but that's on and secure now. So next, what I want to do is route my cable, and we'll take it right back the way it came off. That pops in, snap, we're closed. This one should pop in. Let's do this a little different. Let's move this to there. Give ourselves a little more room now. And that will go there. So we don't have to do that. There. Okay, that's in place. Now we need to reconnect this, snap this together. I'm snapping the connector back together. Don't forget our plastic piece. It has to go in, that holds it in. We'll snap that back in. That's in place. And now all we have to do is, there, if you can see this pin here, it goes in that hole where the other came out of. We pop that in, and that's done. Now, what we have to do is we want to screw this down, get the shaft in place, then we'll take it back off, get the wheel on, torque everything, and we'll be done. Let's go ahead and get that rotor on. And in order to get the rotor on, you want to make sure that these holes where the screws are not where those holes are. You want these holes to be somewhere else, so that if you ever need to put a screw in these to jack them off the hub, that they can do that. So let's put these rotated like that, like so. So we're on here. Now we want to put the calipers and the brakes back in place. Now, one thing you have to know here is these brakes, the way they work, the way a disc brakes work, the way a disc brake works is you've got a brake pad over on this side and a brake pad on that side, and they grip this rotor. And that gripping of the rotor is what applies the braking action to stop the car. Well, when you press on the brake pedal, what happens is there's a couple of cylinders here that press out under hydraulic pressure, under force, and they take this brake and they move it that way. Well, to get it back on here, you have to compress it in a little bit. And the way I do that is I have this wood vise. Works pretty good, and you can just take that and put it on here, and I hear the thunder coming, so I need to move, and I'll compress a little bit, and I'll just put it in the middle and compress that brake in just by turning this so that it's opened up, and that's moving a little bit. It doesn't need much, just enough to make some clearance. And hopefully we can get that over the rotor with a little bit of compression here. So make sure that I'm not twisting my brake line, which I don't think I am. And see if this will slide back on, and it does. So that's why you compress the brake. Take our two bolts back into the brake caliper. So in a car, a whole lot of your automobile. It's a balance of generating power to move forward and managing friction. Brakes are all about friction. Brakes create friction between the pads and the rotor to stop the car. Bearings do the opposite. They try to prevent friction so that things keep rolling, which is why we're putting this new one in today. So when you think about a car again, I don't think we can appreciate too much the value and the meaning of cars in American life. Imagine, for most people, unless you live in a very large city and take public transportation, but imagine what your life would be like if you couldn't operate with a car, if you had no car. Most of us couldn't function. Most of us, the lives we live, would not work without a car. So for me, and I'm going ahead now and tightening up these two bolts that I just put back in. For me, I live about 15 miles away from my work. No way I could do it without a reliable car. It's got to be there. And then I'll come back in a minute and tighten these up with a torque wrench. Okay, I've tightened the bolts on the back of the hub to 90 foot-pounds and got those in place. Now I want to put the wheel back on and get everything tightened down here. And we will fire up the air wrench and get these good and snug. Set this down and then tighten everything up. And then we are done. Let's get these things tightened up. And we'll tighten the wheels up, set it down, then we'll tighten up the center hub. Okay, we'll tighten those to torque specs in just a minute. We're done with this jack stand. We can now get everything out of the way and lower this. And I need to get it going quickly because it is beginning to drip rain. There we go. Let's tighten up that center hub a bit. And then we'll make sure it's torqued appropriately. The last item we have to do here is to torque this center hub to spec. That needs to be at 103 pounds. There it is. Now the lug nuts I think are supposed to be the same. Using a crisscross pattern to tighten these. Here we go. Tighten to spec. Ready to roll. We put our center cap back on, and line up the marks, and that's it. Okay, so our wheel bearing replacement job is now complete. I've given you some information on how to diagnose if a wheel bearing is going out, what was happening on this car. Have shown you how to take a wheel bearing assembly purchased just off of Amazon, have it shipped to your house. You all know how to do that. That's what I did. Had it shipped to my house and just replace it. Went through the steps to replace it. We've talked a little bit about what a bearing is, what it does, the importance of it. Really didn't get too much into the engineering side, but bearings are really incredible devices. There's a lot of engineering that goes into a bearing. When a bearing is designed, when a mechanical engineer designs one of these, he has to take all kinds of factors into account. He has to take the weight of the car into account, the speed that it's going to operate, the hardness of the steel that he's going to use, the life that he's looking for out of the bearing, the type of lubricant that's in it. There are many factors that go into designing a bearing. We tend to look at them and think that they're just kind of simple things and you swap them out, but they really are incredible engineering devices that we would not be able to drive cars or have any kind of modern heavy equipment with things that rotate at high speed. We couldn't have that without bearings. So got a new one in this car. I hope you've enjoyed this video. Hope that you found this helpful and that you may be able to do the same thing, save yourself some money. So on this one wheel, I have about 45 minutes to an hour invested and a total of about $30. Not too bad. So got another wheel to do for the other 30. It's starting to rain. I hope you enjoyed the video. Thanks a lot. Well, the rain has started and I am out in the Trailblazer. Just finished up the repair job about 15-20 minutes ago. So from start to end on this today, I spent maybe an hour from the time that I first started recording the noise as I was driving down the road. So I have replaced one of the two wheel bearings. I replaced the left one, which was the one I thought was making noise, and it's the one that I got out and checked, and I jacked the front of the car up and wiggled that tire, and it did have play in it. So that was the problem, and what I can tell you, I don't know that you can hear it that well in the original video from where I was driving and listening to the problem, but there's complete difference now. The bump is gone, the cyclic noise in the wheel is gone, it's smooth, nothing's vibrating. This car is now driving like it's supposed to again. So this Trailblazer I've had up to one owner. I bought it new and have had it since 2006, and I drove it for several years, and then I gave it to my son to drive as he went off to college. And so it's got now 180,000 miles on it, and the car drives good. You know, what I have learned over the years is that the cheapest car to drive is the one you own. And if you know how to do mechanic work, or you're willing to learn, willing to spend a little energy, you can save some money. And if you like doing this kind of work, you can have a little bit of fun and be a little bit closer to the vehicles that you drive and kind of understand what's going on. This wraps up the video for how to replace a wheel bearing on 2006 Chevy Trailblazer, and this also works for similar years, for Trailblazers, for Envoys. I think old Bravadas, number of cars use this same design. So hopefully you have learned some things you can apply, and maybe you can find yourself doing the same thing and saving some money. And I hope this has been helpful to you. And so this is a wrap for this edition of Ordinary Engineering.